I'm Andy Aldrin. I'm going to be doing the interview. But before we get to the interview, I wanted to show a little video that the students at Purdue put together that I think does probably the best job of describing my father's vision of how you get to Mars that I've seen. How many of you have seen my father speak before? Okay. How many of you completely understood everything? And you guys have all probably got Artemis on right, and maybe me, but this, because there's so much of it, and it's a comprehensive architecture that takes you from the Earth to Mars forever, and it's all there. These guys have done a great job in a very short period of time of tying the pieces together and explaining some really difficult concepts. So we're going to run the video. It's going to go for about 10 minutes, and then we'll come out here, do questions and answers. I've never done anything like this before with my dad, so this is going to be fun and interesting. And we'll have a good time with it, okay?
So with this mission, our primary goal is to establish permanent bases on Mars. But on the way, we're going to use the Moon and Phobos as stepping stones. We're going to be starting off with some international moon bases, and then from there we can move to putting a smaller base on Phobos, operating robotically some cranes and rovers on the surface, and then actually, once we get to about 2040, fully establishing and manning a base on Mars. The moon bases are intended to test all the technologies that we need for the later missions that we're going to do. At the same time, we'll also be doing some testing on the Earth and Hawaii and other places to make sure that all of our modules are ready for the Martian surface and in space.
We will have 3 bases at the moon, one at the far side, one at the near side, and the most interesting of them all, look at the South Pole at Shackleton Crater.
Each lunar base will be composed of 3 second-generation exploration modules.
It is at Shackleton Crater where we will produce rocket fuel from the water extracted from the icy regolith from the moon. We want to produce rocket fuel from the moon because bringing all the rocket fuel to go to Mars from Earth is extremely expensive due to our Earth's high gravity and atmosphere.
The Cycler is a manned spacecraft designed for delivering astronauts to Mars and Phobos safely and efficiently. Analogous to a shuttle bus on Earth, it will be orbiting the Sun and meeting Earth and Mars at regular intervals throughout the mission.
The Cycler vehicle will orbit in an S1L1 trajectory. This trajectory allows for a large vehicle to remain in orbit and for smaller taxi-like vehicles, known as the human landers, to bring humans to and from the Cycler. The S1L1 trajectory is a heliocentric orbit that uses gravity assists at both Earth and Mars to minimize the number of propulsive maneuvers necessary. This solution allows for a larger living space for the humans on their journey from Earth to Mars. Because the orbit opportunity exists each synodic period, but this is a 2 synodic period cycler, we will use 2 cycler vehicles to maximize the number of trips from Earth to Mars. An important consideration for long-duration, low-gravity human spaceflight is the time of flight for the crew. The S1L1 has a time of flight from Earth to Mars of only 138 to 183 days. This short duration allows for the crew's mental and physical health to be maintained. Cycler vehicles will also serve as communications satellites. Once both cycler vehicles are in orbit, we will be able to maintain continuous coverage, even when Earth and Mars are in solar conjunction.
To begin, a boost vehicle will be launched to low Earth orbit. After this, 3 human landers will be launched and docked separately with a boost vehicle. Then, this 4-vehicle assembly will be boosted out of Earth's orbit to meet with a cycler using a hyperbolic rendezvous.
To get the crew from low Earth orbit to the cycler, we will need to perform a hyperbolic rendezvous. This is dangerous. If anything goes wrong, we could lose the crew. Because the hyperbolic rendezvous has never been done before, we will perform 2 tests using cargo to ensure everything goes as planned once the astronauts are ready to make their journey. The first cycler vehicle, Cycler A, will carry 6 astronauts to Phobos. These astronauts will be in charge of surface operations on Mars while we construct the colony. The second cycler vehicle, Cycler B, will come one synodic period later, and it will carry 18 astronauts. 6 of these will go to replace the crew on Phobos. The other 12 will go to the surface of Mars and join the crew of 6 from Phobos. These will be the first men and women to ever step foot on another planet. From there, 18 astronauts will continue to come on each cycle.
In order to meet the 280 kilowatt power demand, we will employ 2 ATK solar panels.
Around Mars, the solar flux available is only 40% of the solar flux available around the Earth. These solar panels are circular and flexible. This design allows them to be very lightweight and to have a very few storage volume.
These flexible wings are 28 meters in diameter and are capable of folding up like a Japanese fan in order to fit inside a small fairing for launch.
The first floor of the XM3 it houses the power systems, thermal systems, water systems, and life support systems, all necessary for crew survival. The second floor contains like a lab space and a group habitat space. On the third floor is the habitat's personal space.
The human lander, or hula, is what's going to be the capsule that contains the first 6 crew members on every mission.
Inside the human lander, there'll be 2 rows of 3 seats each. The astronauts leave the cycler and land on either Phobos or Mars. Either of these journeys will take approximately 1.3 days.
Upon leaving the cycler, the human lander will approach Mars in a hyperbolic trajectory, such as this, where we will be performing an aerocapture maneuver where we skim the atmosphere and then head out either to Phobos or back around for a direct entry at Mars. To enter Mars, we have a heat shield which is mechanically deployable. We will be deploying this in space upon leaving the cycler, and this will take the brunt of the heat force and the deceleration maneuvers. Upon descent, this will decelerate us to a reasonable speed, and then we will deploy a volute in order to decrease the speed even further. The high heating will be absorbed by the heat shield, and the volute will do a lot of the deceleration in the final descent stage. Upon reaching a reasonable terminal velocity, a propulsion system will be ignited, the heat shield will be dropped, and the balloon will be cut. The terminal propulsion system will bring us down to a 0 vertical velocity and cause a hover maneuver where we can move laterally if need be to increase the accuracy of landing. We will deploy landing gear and finally land directly on the Martian surface.
On the Martian surface, the human lander will transform into a rover. The crane will pick up the human lander and place it onto a chassis. The human lander will then be able to travel up to 20 kilometers per hour and go up an incline of approximately 30 degrees.
The main value of the Phobos base is that we're being able to eliminate the 24-minute time delay that can happen between Earth and Mars.
The Phobos base will be composed of 3 XM3s and 2 human landers. This will be the home to the crew of 6.
Back on the surface of Mars, the main colony is made up of 9 connected XM3 modules. 3 in the center as the crew living quarters, 2 additional on the outside to serve as water processing storage, 2 other out here to serve as farming, and then 1 extra core module and another module to serve as the medical bay. Together, these modules form the entirety of the colony and will house at most a 54-person crew.
Even if it were possible for the colonists on Mars and Phobos to be able to produce 100% of their food, water, oxygen, and nitrogen, there are just some things that cannot be produced on these bodies. That's where the cargo lander, or Carla, comes in. Carla is the primary source for all resupply needs for the colonists on Mars and Phobos. The cargo vehicle will be using Hohmann transfers to get from low Earth orbit to the orbit at Mars. Once it arrives at Mars, it will then detach and leave the rest of the vehicle to enter into the Martian atmosphere. Upon landing, it's up for the colonists to locate and retrieve the Carla capsule and bring it back to the main base.
The Mars Return Option, or MARIO, is a series of missions that is designed to bring a crew of up to 6 back to Earth from Phobos or Mars. That is where the Mars Ascent Module, or the MAM, comes in. The MAM will be on top of its own rocket that will then bring the vehicle up to Phobos. From here, the crew of the MAM will dock with the human lander on Phobos and continue the journey back with the BA-330 and the Phobos return system with up to 3 of the crew from Phobos to give us our crew of 6.
Welcome, everyone. Dear Buzz, because this part is directed at you specifically, behind you, as you might have noticed, there is a poster of you on Mars. Some 5 years ago, we put you on Mars as the first person to stand there, firmly planting your boots in the red regolith, blazing a trail for all that will come to Mars behind you, just like you blazed a trail for us on the moon. We felt it just to put you on Mars as you have been advocating humans settling on Mars for such a long time. It seemed only fair. And then the other Dr. Aldrin, who is joining us today, is Andy Aldrin. And for those of you who don't know him, Andy did not really begin a career which would put him on this stage tonight. In fact, his first career was as a Sovietologist working at the Institute for Defense Analysis and RAND Corp. He ended up in aerospace industry either by accident or opportunity and held stints at Boeing as Director of Business Development and Strategy for their NASA systems and launch systems business units. He held a similar role at United Launch Alliance. More recently, Andy took over as a president of Moon Express and recently departed there to pursue other interests, including helping his father, as he's doing tonight, outpopulating Mars with permanent human settlement. Gentlemen, you have the floor.
Thank you very much, Artemis. All right.
Now, wait a minute. All right, fine.
I haven't even gotten my first question out and you're interrupting me.
You got them all. But I get the answers.
I am sure you have the answers. I have a very long list of questions, and I have a great deal of confidence that we'll get through at least one of them. So, these guys have seen you before.
Quick
so
answers. Quick answers.
Quick answers. All right, Dad.
Yes.
No. So that's not going to be appropriate for the first question. The first question is, so the students at Purdue did an exceptional job putting it together. I think, as I told them in introducing the video, this is probably the clearest depiction of the technical aspects of your architecture. But it's thin, and I know there are specific points that you don't necessarily completely agree with, but I'm going to leave that between you and Stephen to argue. But where do you go here with it? What are the next steps for this? I mean, I think this is a good first step. Where do you want to go from here?
Well, you know, I wanted to have, from unbiased academia, a validation of not all the conclusions or the study, but the assumptions that were made that I have had to make to put this plan together. And I thought that unbiased academia could be polled with questions that could have maybe yes, no, maybe, or ABC. A, accept the way NASA wants to do it. C is cancel. And B is Buzz's way. Something in between.
It just strikes me
much better than either.
That it's not a completely objective survey.
No.
But
well, yes, it is. That I'm going to tell them what.
Well, right, you have an object with the survey. I got that.
I'll list all the, but won't tell them.
Okay.
And I, of course, will correct a few little misunderstandings. Not very many, because some of the artwork that they did, it's just phenomenal. I don't quite understand it, but it is beautiful artwork. You know, the aero capture and It's only 1,000 pages. But I was warned of this before, because they've done this a couple times. They did a Mars mission, a simple one, and then they did a lunar mission last year. And so I sort of put them together in the proper focus.
Okay, so today was the release of the paperback edition of Mission to Mars.
Yeah.
Right?
Should have been missions to Mars.
Okay, so I was going to say, aside from changing the title,
See, I
you know,
I read the questions.
When you, Leonard, and I sat around our dining room table and Leonard's dining room table for about, I don't know, 6 or 7 weekends straight, it was 3 years ago now, wasn't it?
Must have been.
So what would you change in the book? Is there anything, I know there's an afterword to it that adds a little bit, but have your ideas changed significantly from what's in the book? And this book is really, I think, a very good attempt to tie all of the pieces together that are more than just the technical pieces of your architecture.
Well, I think I fine-tuned a number of things, put more emphasis, a bit more reality of what might be accepted by the Puzzle Palace occupants here in Washington.
Well, that's leading into my next question.
We of course, need to stimulate the public. Everybody knows that. And that's going to be one of the questions. It's not an ABC, it's 25 words or less. How do we stimulate the public to be supportive of any plan? And I think you do that by having stages of advancement so you can see how you're progressing. And you don't just have a space program that's going to go to Mars. And then public doesn't know what the purpose of these intervening things are. So it needs to be sequential, year by year, evolutionary, improving itself as it goes. Exploration objectives, various ones, that lead toward permanence on Mars. And we'll get to that definition of permanence a little later on, I'm sure.
Rob, can we have the next chart I wanted to get to? Rob, the next chart? Okay, so.
He posed that one.
So there aren't many people, everyone in this room, I think, supports human presence on Mars and making Mars the next focus. Got it?
Could be.
If anybody doesn't,
not, out.
If anyone doesn't, they're probably with the press, but that's another problem. So, but you're probably the only person in the room that might reasonably expect to be walking down the tarmac or the office hall with the next president. So let's just say you get, the elevator ride with Hillary or one of those other Republican guys. What do you say to justify Mars? How do you answer the question, why Mars?
Mr. President.
Madam President.
Madam President, your greatest legacy is in front of you by making a commitment within 2 decades for the United States to lead international humans to permanence on the planet Mars. This can be your legacy and the legacy of the first pilgrims that set foot there, because we know the disadvantages of landing and then bringing people back and then landing again. And that's wishy-washy. What do you want to do? You want to colonize or not? If you don't, stay in orbit. That's nice and safe. Let somebody else go down there. No, I really believe that. But that doesn't mean spend years in orbit. go in there because we have fixed the surface to be a very acceptable, habitable location for growing people. The people who have done that are the ones that are at PHOBOS, because the people from Earth, 6 years before, we've been landing habitable modules and electrical power units and water recovery and the things that are needed. And the modules, you can, from Earth, slowly bring them in a line of approach and then stop.
I'm pretty sure she's off the elevator at this point, but that was awesome.
Okay.
That was awesome.
Oh,
All
how about
right.
that?
All right. So, Dad, Leonard and I have been trying to get you to answer this question for a while. I'm going to try again.
Okay.
First person goes to Mars. First person sets foot on Mars. What are the first words? And it's not buy Coca-Cola.
Well, Pete Conrad isn't around. He said that may have been a small step for Neil, but it was a big one for me.
Still not
No,
going
you
to
were.
are you?
Oh, I need to read. I've got a pocket protector. That's part of visiting Purdue. I mean, there's a gorgeous statue of Mr. Armstrong. And we did a lot of our work in Armstrong Hall. And he's a good guy to fly with, as a matter of fact. I think he knew what he was doing most of the time. But anyway, I have a pocket protector, and it says, I am and ever will be a White Sox pocket protector nerdy engineer. Neil A. Armstrong, 1930 to 2012. I was older than he was. All three of us were born in 1930.
Okay, so I'm not going to get an answer out of you on that. All right. Look, so Artemis mentioned that you've been talking about Mars for a long time. And I know that because I've been around you for a long time. And I mean, it goes back at least to the 80s.
Not as long as Bob Zubrin out there?
You'd know.
No, well,
you would know.
Believe it or not, there was a Mars underground.
That is true.
That was put together out in Boulder. We are now surfacing.
And so that's the point I wanted to get to, is it was underground. And I think it started to come above ground in many ways with Augustine. And I think in particular, the presentation that you made to Augustine, I think, was kind of a watershed.
Yeah, you helped me with it.
Well, yeah.
Yeah.
That may be why I was accepted. You should remember that.
Well, not all of it.
What was it about that presentation, do you think, that had an effect? And how do we make that happen again?
Well, I read the question. Augustine's conclusion was interpreted as a flexible path, meaning we need to develop the capability to do different things depending on what it is we want to do. Well, that certainly was not my unified vision that I submitted. I don't want to get into flying the shuttle a little bit longer, but
that was the part that you screwed up.
The longer it takes to get our people up to our own space station, the more I will say, oh, I had a solution for that gap. Yeah. I think it was quite clear what I submitted to him was we're going to operate from lunar libration points, and we're going to get there with a capability, maybe a Earth-Mars cycle, or Earth-Moon cycler before you get there. I didn't have the foresight that I do now that those two locations are going to be served by commercial crew and cargo, taking controllers up to L1 and L2, and doing that commercially, because Orion is going to cost too much money. It's better to do it commercially. And that opens the potential of, if you only need 3 controllers up there and you got 6 seats in your delivery vehicle, you can take along some passengers, maybe a lot more than you could just up to the International Space Station. And you have some people there, and all you need is a lander, maybe to get somebody down to the surface commercially. Going to the moon and landing is not a NASA job. We've done that. And I didn't give the president the words, been there, done that. That's not the way you treat the moon. You do at the moon things that will enable you to return to a leadership status. And you do that by working arrangements to bring the nations together. And you do not compete with China. You cooperate, you assist people by helping to design what the permanence will be there. On the near side, the far side, Shackleton crater. And you design, and somebody else builds the exploration modules, XM, that are habitats, laboratories, and all sorts of things. But the most difficult thing is I've got one here, I've got a module sitting on top of a lander here, and the next one lands over here. How do I bring them together? Well, I have to decide remotely where I'm going to level the ground the best I can. I got to go take the first one on a flatbed rover with a crane and move it over to where you didn't want me to get into this detail.
No.
But it is not a simple thing like a big shuttle docking with a big space station with very fine control of thrusters. There's a gravity field, an uneven terrain, and you have to make connections for pressurized transfer, for fluid transfer, computer connections, electrical, all sorts of things. You got to do that remotely. You're not going to have people down there putting these things together. It has to be done remotely on the moon. But we're going to check them out on the big island of Hawaii, make mistakes, fix them, make mistakes again and fix them. We're going to do it remotely from Houston or someplace.
Okay. I'm going to, I've got more questions. We're going to have more fun here, but I'm going to let the audience have a little bit of fun for a while. So do we have any questions? Do we have a mic that we can get out there?
I got my hearing aids in.
First, right here. Okay.
Yeah, why is it necessary to have humans colonize as opposed to just having automatons, rovers? Why is the human element so important?
Okay, so for those who didn't hear it, the question was, why is the human element so important? Why do you have to have humans colonize and not robots or automatons?
There are a whole lot of philosophical reasons about we explore or we expire. It is built into our human genes, the curiosity to look elsewhere, to find better locations. What's on the other side of the mountain? What will enable me to begin to continue to explore? And sometimes people say we want to preserve the human race against pestilence, nuclear war, impact of large objects. That's kind of trivial. The dinosaurs didn't have a space program, but we do.
Talk about heavy lift. I didn't say that.
You know, if a big one is coming, a big one, really big, The latest thinking, and I had to listen to some of these experts, is we're going to use nuclear detonations with shock waves, not to blow this thing into little pieces. That makes things a whole lot worse. But supposedly, it can be diverted by a big shock wave. Last time I checked, NASA did not have any of those. NASA doesn't have people on alert, but the Defense Department does, and that, to me, the highest level of national security is where our planetary protection should
So let's see if we can get another question in here. Chris, I'll let you pick them. I think we've got one right here.
Thanks. You mentioned the first words on Mars. I'm curious, as to someone who landed the LEM on the moon, what would your advice be to someone who lands the LEM on Phobos or Mars?
I put some words together in my science fiction story. I forget what it was, but it said, those were good words of, as a tribute to Neil Armstrong. So we're going to make a big leap, but the gravity's pretty low on Phobos, so it's pretty easy to jump down. It's going to be a magnificent desolation? No, it's going to be a wonderful settlement here. Let's stay a while. First words.
Welcome home?
Home? No, that's what he says to the second person.
Okay. Okay, one more.
No, he's got a bunch more, I tell you. Unless you...
Oh, I'm sorry, did you already have someone? I'm sorry, someone.
Have you picked somebody?
Buzz,
Someone?
I've met you a couple times
He has the
before.
magic stick.
The last time we talked was at Cafe Milano before the Army-Navy game a couple years ago.
Army lost.
They did lose.
Didn't have to have much of a memory for that.
Unfortunately, we're not going anywhere without money. So I wanted to just talk about that a bit. You once said they promised me Mars colonies and they gave me Facebook. And the irony of that is we wouldn't even have Facebook and mobile phones if we didn't have an Apollo program. Because putting the onboard circuitry and the guidance systems and everything, making things smaller, is the very reason we have iPhones now. So I guess what I'm saying net is we need to get the public to stop looking at this as an expenditure and look at it as an investment with all these new industries created, et cetera. Anyway, with that in mind, what of all the technical risks out there, I know the investors behind SpaceX, et cetera, what is the number one technical challenge that we need to get money behind, both publicly and commercially?
The public desire is the most important. I wanted to talk to Scott Hubbard because I read about his study. I think in place of asteroid redirect, he was going to do a study within our affordability or something like that. And they're going to put spacecraft with humans somewhere in Mars orbit by 2033. And then they'll come back, maybe look at Phobos. And then a few years later, they'll send a crew that'll make a landing in 2039 for 30 days, and then they'll come back. And adjusted for inflation, they were very happy that this could be done under present budgetary restrictions. God, that's like telling OMB, we don't need any money. Yeah, took 4% for a couple of people to kick up dust on the moon a few years ago, and now in a much more ambitious activity for permanence? You're going to do it with 0.5%? Come on, you got to be kidding. Doing great things takes great people to make some sacrifices for what it will bring us in a return in the future. To me, the most important is a commitment to do something appropriate for the future of humanity. And I know Andy doesn't agree with this, but some policy wonk wrote a book, Why We Went to the Moon, and in it he enumerated why 1961 with JFK was so special a set of circumstances that it never happened again. We need a destination, a clear destination, a time, and a plan. And with those and the people behind it, because the people will see to it that we are able to afford to do great things in keeping with a great nation. Those were Norm Augustine's terms.
So let me pick up from there.
Thanks.
And say that it clearly will require a commitment, probably more than even the United States can afford by itself. So it's going to require an international coalition.
Oh, that's part of the commitment.
So let's talk about international agreements, international cooperation. What do you think the international team looks like that goes to Mars? Is it just a space station team? Is it just a space station structure? Do you bring in new players?
Well, I don't think it's the Antarctica role model or model, but I don't think it's really the space station either. With agencies and countries and ministers, before a space agency or a nation can make a commitment, they got to check it out with the ministers, because they have an agreement that if they put a certain amount of money in, regardless of how talented they are, they get a certain amount of work to perform. I mean, it's another jobs program, and we know what that does to a nation's future objectives. I think it has to have an agreement among the nations involved that there is a leadership of sorts, and that leadership is experienced, and it can distribute in some way the capable work projects that need to be done, that other nations want to be able to do. Prestige is a good bit of the motivation for sending humans somewhere, so that your citizens will see that your country does have a great system, and you're showing it that the sacrifices that the country is making, whether it's an autocratic dictatorship or it's a free country, you need to have these folks working together with what their capabilities are. And to me, an example of that as part of the last parts of the Apollo missions were Apollo-Soyuz. 1975, missiles pointed at each other, mutual assured destruction. That was the Cold War, and it was pretty contentious. And yet, both nations agreed to demonstrate this mutual docking led by the United States. What was the result of that? Well, it defused the competition in a sense, and it moved on, survived through the breakup of the Soviet Union, and it continued with the basis of Skylab and Salyut space stations to come together in an international cooperative manner with the Mir space station, the International Space Station, and future outgrowth of that. Threats now may exist because President Putin may want to use the space station as some element of national objectives. Not sure what those are, but it's not quite as peaceful an exchange. It's friendship at the International Space Station, that's for sure. But what happens next? It's expensive to support that space station, and it's inefficient for payload delivery up there at a high inclination. Some people have talked about a commercial space station, taking the lessons learned. Sure, in my study, my sequential, first thing I would do is not wait for Orion SLS. Let's take our commercial delivery capability and spacecraft and put an inflatable Bigelow BA-330 at low Earth orbit, 2018. The second one, they say, will be ready in 2019. Let's put that at L1. And we can send a Dragon there. Maybe they'll have to beef up their heat shield a little bit. But people on that crew on July 20th, 2019, can look down on the 6 landing sites of Apollo as back here on Earth. The golden Apollo legacy is celebrating the benefits that came from that program and how we are looking forward. Not backwards, but we are looking forward as a nation. And we can expand on those facilities at L1 and L2, making sure that we have the ability in place there before another nation needs to begin permanence, 6-month stays, something like that. We're not going to compete, I hope, with China. We're going to demonstrate to them that we're doing things to help them cooperate and bring other nations together. And I think that we can do that, certainly, at the moon. And we can take inflatables and Orion and go to an in-place asteroid and have a robot arrive there with SCP propulsion 2 days after the crew gets there, and 2 astronauts and an asteroid scientist expert and a robotics expert who built or designed what they're looking at outside the window. For 60 days, they're going to be combining a manned mission and a robotic mission. Other visits to asteroids later on cannot afford to send humans at the same time. This is an opportunity when we're expanding human mission capability and robotics, and we put them together. Why does some fighter pilot, egghead from MIT, have to come up with what Washington should have known with the human spaceflight people and the scientists? We know things are wrong with a science mission only. They got to do time delay, automation or delayed communication, 15 seconds, 30 seconds. It's pretty sloppy. Human mission, they can open up the hatch because there's no airlock that I know of, and do an EVA quite a ways away from home. We got to come back home again. But you put both those missions together, and they both benefit tremendously. Okay. And we can do that again. Once we put enough rigid modules, put them together, somebody else is going to land them because somebody else is going to build them.
Okay, Dad.
And then we can send a rigid flyby of Venus.
Okay.
2 ladies are going to go to Venus.
All right. Okay, Dad. So
Yeah.
you're 85 now, and as everyone in this room sees, that there's absolutely no indication that you're slowing down. But I got to accept that sometime in the next
Where's Judy?
30 years, where's Judy? Well, I'm not going to get into that. Sometime in the next 30 years, you might not be around. So how do you want to be remembered? I mean, it will always be Buzz Aldrin. He was on the first mission to the moon, but the greatest achievement that he made was what?
Always a futurist, always serving his country, outward toward the stars.
Okay. All right.
Is that good? I just thought of that. Huh?
With that, Dad, I'm going to turn it over to the audience again and see if they've got some more questions for you. So I don't know if Chris has some microphones again. We've got a couple of microphones. All right. Someone's holding the magic stick already.
Yes, thank you very much. And thank you for taking our questions this evening. I wonder if you could speak a little bit about some of the advantages and disadvantages of government agencies versus private industry branching out deeper and deeper into space.
We're going to have both of them. It's how they're going to get along, I think, and they must get along. We can't do things with just government. We've done enough government projects to know, but usually the private sector can do a better job. Anybody from Huntsville?
Next question. I actually had chosen her for a question earlier, and she got usurped, so let's let her have a shot at it, please.
Hi. I don't know enough about this in terms of I have learned about this through my kids, but there's a Mars One initiative from the Netherlands.
Yeah.
And when you speak about collaboration, have you been engaged with this initiative of Mars Ones, and how would you picture the collaboration between countries? As you mentioned, we don't want to compete with China or Russia, but how do you envision the collaboration between the countries? Thank you.
Let's separate the funding to carry out the mission. Before they announced what they were doing, I could see a civilian group of people somewhere wanting to say Mars One. One-way trips, that's too discouraging a terminology, and I wouldn't want to use one way. We're going somewhere to settle. That's what I'm talking about, too. Yeah. It certainly got people thinking about going to Mars and building up a permanent presence there. NASA likes the word pioneering, but I don't think they're quite as specific as maybe they should be. A settlement, a colony. To me, that means you can explore, visit someplace, and this would be a good place to have a settlement or a colony. And you go back home and you talk it over, and then you go back out again and you look and you pick the place that you're going to go to specifically. Then you come back and you get things organized, and then you go and you have a settlement or a colony. Now, maybe that's pioneering. You're going to live off the land. But when you look at what it means to be in orbit around Mars versus controlling something from here on Earth to what's on Mars. As Steve Squires has said, what Spirit and Opportunity did in 5 years of their trek could have been done in 1 week if we had human intelligence in orbit at Mars to speak directly to those two rovers on opposite sides. That is powerful. The time of communication and then seeing what is happening as a result of your communication. Robots need to be watched very carefully. They don't think too well yet. So we have to be very conservative, and they get into anything unusual. Stop, don't do anything. We'll figure it out.
Before we get into an anti-defamation suit against robots, let's get to the next question. Chris?
Glad you're around, if they think so too. Okay.
Since it's going to take a world effort to go to Mars, whose flag will be on Mars?
Yes, it'll be a world awareness because it's going to take contributions from all the nations participating who will get the benefits of the technology that's going to be developed. There was the last part of the question.
Whose flag? Whose flag gets planted? It's a very good question.
UN? Whoever gets there first.
Okay. All right, next question.
Okay, I just wanted to know, as an astronaut back in your day, what was the catalyst for you becoming an astronaut? What was your reason for becoming an astronaut and aspiring to, set foot on Mars?
I had an aviation background and chose not to be a test pilot. Some people are born in an airplane. They're just at home right from the beginning. And some people learn better to get used to things. I was one of those. I just didn't want to be a stick and rudder guy in the Air Force. So I wanted to do more future things, but in the meantime, it's fighters and nuclear weapon delivery, if that's what we need to do. But I really didn't want to go through test pilot training, so I didn't. And then I read in Life magazine that if you're not a test pilot, you're not going to get to play around in this new game of space. I was discouraged. I went to MIT anyway and figured out, well, it's an extension of flying, an ideal pursuit curve to shoot down another airplane or get a good score on a target. And that ideal pursuit curve, intercept, that's the way we ought to do rendezvous. Well, people hadn't quite thought of it that way, but you could set it up so that you could do just that. And that finally was the accepted way of doing the Gemini program. And the guys were familiar with that, so that's what we did essentially in Apollo. I wasn't going to even fly in the Gemini program. You know that? The guy who taught the first cruise, helped McDonald train the first cruise to do rendezvous. I wasn't going to even fly in the Gemini program. That's an egghead from MIT in competition with Navy night landing carrier test pilots.
Okay. Chris, maybe two more, right?
How are you going to keep the inflatables from popping?
You put a regulator in them, a relief valve. Don't fill them too full. Hey, I heard an MIT, I went to MIT, but I heard an MIT evaluation of Mars 1 They're going to grow plants, and somehow growing these plants inside is going to cause the people who are there to die pretty soon because they got too much oxygen. Can you imagine? They're making oxygen out of plants, and we think it's a bad thing to do? God, that sounds like a great thing to do to me. Why would you get into the legal arguments of whether this is suicide mission or not? These people are inspiring people to think about a natural way to transport people from one place to another. Pilgrims on the Mayflower, they want to hang around Plymouth Rock for the return trip. Now they came here to settle. England sent prisoners to Australia. They didn't want to go back in jail.
Got one right here.
How'd you decide who would be the first person to step on the moon?
Well, I'll give you my speech version. There was a lot of discussion about that. We're sending 2 people. You know what the president said? I want to send a man to the moon and bring him back safely. He didn't say anything about opening the hatch and going out and walking around. There was an add-on. He got more for his money than he was looking for. But he didn't say send a woman to the moon and bring her back safely. We didn't do that either. So we decided to send 2 people. Well, now what do? Do you send both of them out at the same time? Well, the ladder wasn't that big. Well, the commander really has to train on a lot of things that are very important. One of them is rendezvous. One of them is landing. That is the most difficult thing. Usually the also their co-pilot, that we call the pilot, he does the dirty work of experiments. So we kick him out first so he could, no, but wait a minute, this is very symbolic and commanders have to go out first. But what I say in my talks is it might have been because who was closest to the hatch? But I'm not going to tell you.
Chris, one more.
Hi, Buzz. I'm sorry.
Hi.
I had the honor of shaking your hand in 1989 at the 20th anniversary of the lunar landing when I was starting my career, and this was at Johnson Space Center at the Gilruth. Remember me? Probably not. But since then, I was an EVA specialist, and I watched us have all kinds of problems on, well, we had a lot of successes, but problems too. And that makes me a fan of the moon as a test bed to learn how these systems are going to work. I'm a little confused, though, because I've always known you as we've been there and done that. Why would you ever do that again? And I'd like you to kind of explain your stance on using the moon as a test bed prior to going out to Mars.
Well, I didn't say been there, done that. That's kind of a crass statement about a very important challenge for many, many nations to want to send their citizens there. We can do many things that we need to learn how to do very well, and that is to build a permanence and bring those modules together. We need to know how to do that remotely on Mars from Earth, bring them close enough so that then when a crew gets close, they can do the final bit. There are many things that really can be done as we learn more about the power supply that's needed for a settlement on the near side, the far side, Shackleton. That's where we get the ice, the water. Without the fuel, hydrogen and oxygen, going to Mars would be extremely expensive, much more so. I don't agree with NASA and refueling at lunar distance. I'm not that supportive of a distant retrograde orbit either, but be that as it may, there may be some use for it. I would bring an asteroid, a rock, back to the low Earth orbit if I had a choice, but I'd really go to an asteroid with a robot and a crew.
Okay, Dan. We have
Thank you.
one more question from the future astronaut in front.
Are you planning to go to the mission of Mars?
Are you planning to go to Mars?
No. I might send him. No, I'm reserving my thrust for the 50th anniversary of the Golden Apollo legacy. Legacy of Apollo is going to guide this nation into future greatness. And it'll provide a legacy for this nation's leader if they'll only recognize that they could make a commitment for U.S. leadership of international nations within 2 decades to begin permanence on the planet Mars. If you don't think that's going to provide a legacy for that world leader who makes that commitment, just think a little bit about 100, 200, 500 years from now. Who will have done as much for the future of humanity than to establish a residence, a development on another planet?
Okay. I can't think of a better set of words to finish this off with. Dad, thank you very much. Thank all
you.
of you.
Yeah.